The cosmic region near us is not merely a void sparkling with stars. For example, asteroids are not just chunks of rock. They're like living time capsules from the cosmos. Consists of primitive materials similar to the composition of planets, but unaffected by weathering or geological processes. Asteroids often contain materials that were destroyed long ago by geological processes on Earth. Recently, NASA completed the mission of bringing the first sample from an asteroid back to Earth. What have scientists discovered in these meteorite fragments? Could there be any seeds capable of sprouting on them? In 2016, NASA launched the groundbreaking OSIRIS-REx mission with the goal of collecting samples from the surface of Asteroid Bennu. After nearly 2 years of searching for the ideal landing spot, the OSIRIS-REx spacecraft finally touched down on the asteroid's rugged surface. But because the asteroid's surface was too fragile, the spacecraft had to operate very quickly. At the same time, it fired its thrusters to break free from the asteroid and prepare for takeoff. In less than 30 seconds, the spacecraft's robotic arm dug a 0.5-meter deep hole on the asteroid Bennu and obtained a rock and dust sample with a total mass of 250 grams. After leaving the asteroid and orbiting it a few times, the OSIRIS-REx spacecraft returned to Earth. From a distance of 101,000 kilometers from Earth, the spacecraft launched the probe carrying the long-awaited samples back to our planet. On its journey, the spacecraft is hurtling toward Earth at a speed of 43,000 kilometers per hour. And concluding a 7-year journey, covering a distance of 6.5 billion kilometers by landing in the Utah desert. In clean laboratories, scientists began analyzing samples from the asteroid to search for traces of extraterrestrial life. And these clues could help unravel the mystery of the origin of life on Earth. When scientists first observed the sample, they discovered a small amount of dust from the asteroid clinging to the outer lid of the main container. The strange thing is that the energy core is very carefully protected. So how can dust still get inside? When the OSIRIS-REx spacecraft landed on the asteroid, it created a shockwave, causing some surface material to scatter into space. Some debris from this material had stuck to the sample collection head. Immediately after gathering was complete, OSIRIS-REx promptly sealed the lid. The small holes allowed dust particles from the asteroid to escape outward. The initial fragments were discovered outside the main collection chamber and are now being meticulously examined. The scientists still haven't managed to open the energy capsule, so most of the material remains sealed inside. So, how can a speck of cosmic dust or a piece of space debris reveal to us the secrets of the solar system's earliest days? And could this help unravel the mysteries of the origins of life on Earth? The water present on Earth today is even older than the planet itself. This led scientists to believe that the object originated from outer space. Besides water, asteroids may also contain important organic molecules. Scientists examined the black powder of extraterrestrial origin, collected from around the edges of the energy capsule. Under the scanning electron microscope, 3D particle models were generated and chemical analysis was performed. Discoveries from this small sample have yielded extremely fascinating results. The levels of carbon and water-bearing minerals are surprisingly high. Such discoveries are of great significance in helping us understand the fundamental components that make up our celestial region. The formation process of planets and the potential role of asteroids. Billions of years ago, the elements that form life began to take root on Earth. The scientific community believes that not only water but also life itself could have been brought to Earth by celestial bodies in the universe. And an asteroid collided with our Earth at some point far in the past. Previously, astronomers have discovered the fundamental building blocks of life on extraterrestrial celestial bodies. For example, scientists have discovered that the asteroid Yuzo contains urazine in its composition, a compound used to produce genetic material in every living cell. Niacin, also known as vitamin B3, is an essential nutrient involved in metabolism, helping the body produce energy. Even before that time, scientists had discovered organic molecules in celestial bodies that fell to Earth. But the question remains, did they come into contact with Earth's environment after landing? Some astronomers believe that we currently lack the technology to explore life in the Milky Way. By studying distant planets outside the solar system, But instead, we can focus on studying cosmic dust. In short, asteroids frequently collide with distant planets, causing violent impacts that send debris flying into space. If some of these planets are capable of sustaining life, the particles of matter ejected into space could carry traces of life's presence on them. Even tiny dust particles, just about 1 micrometer in size, are large enough to store this information. But also light enough to be ejected far into space during such violent collisions. At just 1 micrometer in size, these particles are so small that a grain of sand next to them appears as massive as a boulder in comparison. With their compact size, these particles can traverse the Milky Way at an astonishing speed. Propelled by inertia, due to the collision and encountering almost no resistance in the vast expanse of space. Some of these dust particles may actually fall to the Earth's surface. Astronomers estimate that about 100,000 such dust particles fall to Earth each year. It's not just asteroids and extraterrestrial debris that can carry life-forming molecules. A study has discovered interstellar clouds, the birthplace of new stars. In the laboratory designed to simulate a space environment, the scientists conducted experiments with the common types of ice found in these massive clouds. Ammonia, carbon dioxide, water, and even methanol. These ice blocks were bombarded with high-energy protons using a Van de Graaff generator, simulating cosmic conditions in space. As a result, the ice molecules break apart and then recombine, forming more complex molecules. Amine is an organic compound containing a nitrogen atom, similar to amino acids. When our solar system formed, these molecules traveled on carbon-rich asteroids. Our carbon-rich asteroids eventually made their way to Earth through collisions and space stations. Another study suggests that if asteroids retained their warmth after formation, some molecules can double in quantity within just 1 week. And this means the interstellar dust cloud, where our solar system formed, had emerged, may have already contained the essential elements for life long before Earth was born, and create conditions for them to thrive in a safe living environment. Currently, astronomers are focusing their research on the asteroid Bennu to gain deeper insights into it. Does it contain any other precursors for biological activities on Earth? But we need to be patient and wait for more detailed information. Although exploring the history of the solar system and the origin of life on Earth is incredibly fascinating. However, there is another reason why scientists are interested in studying the asteroid Bennu. This asteroid is considered a potential threat, and astronomers are currently working to predict its future trajectory. To this day, they still believe an asteroid could collide with Earth. The period from 2175 to 1196 BC is roughly 1 in 2700 years. Although the probability is quite low, Bennu remains one of the 2 most dangerous asteroids in the solar system based on what we currently know. And certain current factors could alter the trajectory of asteroid Bennu. Because this asteroid is taller than the Empire State Building and about 7 times wider than it. Even the slightest change in its trajectory could send it crashing into Earth. Scientists are diligently researching to predict Bennu's trajectory far into the future. They used observation and calculation to predict its orbit around the Sun. But things got complicated because Bennu is not only affected by the Sun but also influenced by the Moon, the planets and other asteroids as well. Astronomers have identified 4 specific times when this celestial object will pass by Earth in the future. In 2060, Bennu will be twice as far from us as the distance to the Moon, but its exact position cannot be determined. And though it may seem small in the grand scheme of the universe, but even such small errors can significantly impact the calculation results. Imagine Bennu as a car taking you to an unfamiliar city. If you deviate even just 1 degree from your initial direction, by the end of the journey, you'll have traveled a much longer detour. Just like when you take a wrong turn at a highway junction, the farther you go from that point, the more off course you become. By the year 2135, asteroid Bennu is predicted to come closer to Earth than the distance between the Moon and our planet. But accurately predicting its location will be no easy challenge. After the closest approach in 2135, this distance will continue to increase, and the calculations become more tangled and harder to manage. And then, the Yakutsky effect emerges. a drag force acting on a celestial body rotating in space. This has nothing to do with gravity, but rather the heat radiating from the sun. When an asteroid is illuminated by the sun, the side facing the light heats up. As the asteroid rotates, its heated surface gradually turns away from the sun. When exposed to a cold environment, the body releases heat outward. This continuous heating and cooling generates a slight thrust force acting on the space object, gradually altering its direction of movement over time. According to scientists' calculations, this force causes the asteroid Bennu to deviate from its orbit by approximately 290 meters each year. And this is how the asteroid moves from the region of space between Mars and Jupiter, coming closer to Earth and the Sun. Although the probability of Bennu hitting Earth is less than 0.4%, this risk is still 5 times higher than the chance of being struck by lightning. It's also possible that the researchers miscalculated, causing the asteroid to hit Earth. If Bennu were to actually hit Earth, it would create an impact crater 6.4 kilometers wide and flatten all surrounding cities. Hopefully, astronomers truly understand the work they're doing. Meanwhile, the OSIRIS mission still has a long way to go. The expedition team has been renamed OSIRIS-REx and is currently heading toward a near-Earth asteroid named Apophis, which has a diameter of 365 meters. In the near future, the asteroid Apophis will pass extremely close to Earth. But the question is, how close is it? When the Moon is at its closest position to Earth, it is about 355,000 kilometers away from us. Meanwhile, the asteroid Apophis will approach at a distance only 1/10 of that, or roughly 35,500 kilometers. In 2029, this event will occur, and by 2068, there is a slight chance it could collide with our Earth. The goal of the OSIRIS-REx mission is to catch up with the asteroid Apophis a few months after its close flyby of Earth, then enter its orbit to analyze its composition while measuring its size and determining its exact shape. Asteroids of that size only approach Earth once every 7,500 years. But meteorites are not rare objects, though there is still one thing that puzzles scientists. This 10.45 kilograms stone was discovered in the Sahara Desert a few years ago and is likely the first meteorite of its kind, NWA 13188, ever found on Earth. The initial test results indicate this object is made of the same type of volcanic rock found on Earth. But that's not all. This object also contains isotopes proving exposure to a micro-universe, while possessing a glossy surface known as a fusion crust. This phenomenon occurs when a rock passes through Earth's atmosphere before falling to the ground. Therefore, scientists believe this rock fragment was ejected into space around 10,000 years ago when an asteroid struck Earth. Then, it drifted for thousands of years in the space near the solar system, until Earth's gravity finally pulled it back. If this hypothesis is correct, this would be the first rock to leave Earth and then return. Another notable meteorite named El Ali was discovered in 2020, with an exceptionally large size and mass. This rock weighs up to 16.5 tons, but what interests scientists isn't its size. Inside, they discovered 2 entirely new types of minerals, previously unknown to science and never before found on Earth. 2 newly discovered minerals have been named ellalite and elkanthonthite. Currently, only a small fragment has been studied, but clues about a third highly promising new mineral deposit have already emerged. Currently, scientists are researching to discover practical applications for extraterrestrial minerals. The minerals crystallized when the molten meteorite solidified. The reason these space rocks heat up to extreme temperatures is due to their collisions at astonishing speeds, reaching over 3,000 kilometers per hour. In our solar system, there is only one place where this phenomenon occurs regularly: the asteroid belt located between the orbits of Mars and Jupiter. And who knows what other extraterrestrial minerals are still waiting to be discovered. Meteorites not only possess unique compositions but also come in countless forms with bizarre atomic structures. Since ancient times, scientists have always believed that crystals only exist in fixed, symmetrical shapes. But in the end, the theory of quasi-crystals was also established. Ordinary crystals like diamonds or snowflakes all follow strict rules. But quasi-crystals completely disrupt that structure. They have an orderly structure, but their patterns do not always repeat. Humans are incredibly creative, which is why scientists have invented ways to produce it. But we still need to see whether such crystals exist in nature. Later, Italian geologist Luca Bindi and his research team discovered a small fragment of a quasi-crystal in a meteorite that fell in the Far East region of Russia. And the astonishing thing is that within the same meteorite, not just one but as many as 3 different types of quasi-crystals were discovered. Among them is a type that has never been seen before. Quasi-crystals have a structure resembling tightly packed pentagonal tiles. Atoms cannot fit together perfectly, but different atomic shapes will fill those gaps. If asteroids are like messengers carrying life throughout the universe, would you believe they've sown the seeds of life on other planets? What strange chemical compounds could govern those distant worlds?